In the previous video, we looked at three main ways to manage objects in Kubernetes. In this video, we will look at the Helm package manager, which is widely used in the industry. Helm is an open source package manager for Kubernetes. The package manager can be used to package, deploy, scale, delete, upgrade, or roll back applications to Kubernetes. Think of Helm as doing two things for you. The first is that it makes it easy to package and install standard applications such as Grafana, Nginx, Elasticsearch, etc. The second is that it makes it easy to manage the deployment of your own enterprise applications, such as microservices or web applications, by easily integrating with the CI/CD pipeline. Let's look at some of the core concepts of Helm. The deployment information for an application is packaged in a unit known as a chart. Each chart has all the information and configuration required to install, version, upgrade, or roll back an application and its dependencies. For example, the Grafana chart can be used to install Grafana and its dependencies to a Kubernetes cluster. The chart itself is stored in a repository, and the standard repository is located in Helm GitHub in the charts repo. You can create and host your own repositories to store your application charts. The chart has the following structure. At its root is a directory with the same name as the chart. So if your chart is called Spring RESTful API, that's the name of the root directory. Inside the root directory, the first required file is called charts.yaml. It contains the metadata about the chart, such as its name, description, version, maintainers, and source. The second important file is called values.yaml. It stores the configuration information in a YAML format. Charts contain an optional file called requirements.yaml. It contains a list of dependent charts and their versions. A chart also contains a directory called charts, where you can download and store the actual dependent charts. Although it's a better practice to specify dependencies in the requirements.yaml file, there might be cases where you might have the dependency as an archive or exploded directory inside the charts directory. A chart has another important directory called a template. Templates are what give charts their power. A template is a code template that allows you to use the values from the values.yaml file and other variables to create a Kubernetes manifest file. Templates allow you to use code template syntax such as functions and control structures to generate complicated manifest files. We will look at templates in the next video. There are three other optional files that can be provided to make charts and the deployment more informative. The first file is called readme.md that contains information about the chart. Another file is called license and it stores the license information. The last file is inside the templates directory and is called notes.txt. It contains additional information that is provided to the user as an output from the chart install command. Helm itself consists of a client-server architecture where the server is called Tiller and is generally deployed as a pod in Kubernetes itself. Every time you install a chart, it's called a release. So for example, if you install two instances of Redis, you would have two Redis releases from the same chart. This finishes our introduction to charts. In this video, we have learned what charts are and saw a breakdown of its structure. In the next video, we will look at how to write and use templates, and in the later video, we will write our own first chart to deploy the Spring Boot API that we deployed earlier using the kubectl apply command. See you in the next video.